Okay, so here I'm going to talk about the absolute basics of forces. Now, forces is something which we encounter all the time. I'm making a force on the table now when I hit it. You'll also notice that if you do that, then the table gives a force back to you. Okay. Now, forces must always include a direction. Again, I'm doing this, and I can definitely say there's a particular direction to this. It's into the table. Now, if I poke this way, okay, there's a direction to this, moving sort of perpendicular to the pen. If I do it this way, though, there's some perpendicular force. There's some of the forces in this direction. You can see the pen moves, but there's also a little bit to the side. So a force like this on an object like that, some of this is partly, well, it's mostly in the y-axis, but there's a little bit in the x-axis as well. That's something that we're not really you don't really need to worry too much about at GCSE, because normally we just look at forces at right angles, or we just describe what's going on. So anyway, we've got a lad and he throws a ball. Now, where is the force coming from when he's throwing the ball? Well, the force is coming from his hand, isn't it? And as soon as that leaves his hand, well, once it's in his hand, there is this force here. We'll just make it nice and simple. We'll say there's a force in that direction. Now it's moving, so there is going to be a little bit of air resistance, but you can see there's a bigger force in this direction. What that's going to do is it's going to accelerate in that direction. It's going to accelerate this way. So there's stage one. But once we get to stage two, it leaves his hand. So let's say stage two is here, but it's any time after it's left his hand. There is no longer any force this way, and there can't be, because it's not touching him. There's nothing that's given that forward force. But it's still moving. It's still moving forwards. It's still moving in this direction. Well, actually, in fact, it's moving more in this direction, isn't it? Because there's gravity as well. Gravity is moving on it. So that's the move. Is moving on it. Gravity's working on it. So it's moving that direction. But this is the really important thing. Forces are not the same as movement. That's why we've got two different words. It's not the same. They are related, but they're not the same thing. So at stage two, what we're going to do is we're just going to show the arrows for the forces. Okay, and the size of the arrow shows you the size of the force. So here we have got the weight of the ball. And here we've also got that air resistance is still there. Now what that means is it's going to accelerate in this direction. That means because it's moving this way, but the acceleration is back that way, it's going to slow down. Okay, so the ball's moving this way, but it's going to slow down this way. But this also means it's going to accelerate down towards the earth. Now, because this is caused by its weight, we'll just write weight there. That's not going to change. So when we get to stage three, the weight is the same. But because it started to move downwards, there's going to be a little bit of air resistance here. Okay? Its movement away from the boy, it's slower. So that means that this air resistance is going to be less until just before it hits the ground. Let's give some ground here. Just before it hits the ground, the weight remains the same. We're going to write W, W, W. Weight remains the same. Now, because this has been accelerating this whole time, its other air resistance is going to be equal. Is going to be higher again. And it's hardly even moving this direction at all by the time it hits here. So there's only a tiny, tiny amount of air resistance there. Now, what I'm going to do is we're going to use this and we're going to develop this a little bit more, and we're going to think about a slightly more complicated situation. So let me just, So I apologize for my crude drawings, but we're going to look at the forces and the motion of a person who is doing a skydive. And we've also got a speed time graph here to help us to think about what's actually going on. We're just going to sketch the graph. So here we've got a person inside the airplane. In this case, we're only thinking about the forces on the person. Now there's one thing which we can say is going to be the same throughout, unless they vomit or something. And remember, we're keeping this nice and simple. And that is the weight of this person. Their weight is not going to change. So we'll do that arrow around about the same length every single time. Okay? So their weight will be the same every stage of this. Okay? Right now, we're not thinking about any thrust or air resistance on them because they're inside the plane. We're just thinking about it. Right now, they're not moving with respect to the plane. And we're just going to think about the vertical forces in this. So again, we're only thinking about the vertical speed as well, by the way. So at first they jump out, and their weight is making them accelerate towards the earth. There is a tiny bit of air resistance because they've just started moving, but they're still accelerating. Now when we get to stage 3, they've kept accelerating, and when you get faster, air resistance increases. So at some stage the air resistance is going to be equal to the weight. So we could say negative W. Okay, so it's going to be equal to the weight. That's the air resistance. And let's look at stages 1 to 3. What we're getting is increasing speed. But as the speed increases, so does the air resistance. So that means the acceleration is going to get less and less until those forces are balanced. So at this stage, we say the forces are balanced. Okay? That means that the speed is not changing. The speed is not increasing. So what we will get is a graph with a decreasing gradient. And that shows decreasing acceleration until they get to a steady speed. This is at that steady speed. Now the next thing that's going to happen is they're going to pull their parachute because they don't want to land without a parachute because that'd be very uncomfortable and painful. And what we then get, as soon as the parachute opens, we get the air resistance increases absolutely loads. You get a very large increase in air resistance. Because of that, that causes the person to slow down a lot. That causes them to slow down quite quickly as well. So then what we're going to get is a pattern a bit like this here, until they reach a safer steady speed. So at the moment the parachute gets open, the air resistance increases a lot, so we get a big decrease in speed. And then from that point onwards, let's just go to 5 here. Because they've slowed down, the air resistance also decreases. So once we get to stage 5, which is about here, we look at our person, we've got our parachute. Let me try and draw it slightly better this time. There, that's way better. What we now have is their weight, and because they're moving much more slowly, the air resistance is equal to the weight again. And that means, again, the forces are balanced and they're falling at a constant speed. So let's look at this then. Stage 1 we don't have on the graph. This is stage 2 when they're accelerating the most. Stage 3 when the forces are balanced. And then stage 4 is when the parachute is opened. Stage 5 is when the forces are balanced and they are at a steady speed. So that is, if you can understand this, that is everything you need to know about the principles of forces and of balanced and unbalanced forces. There's a little bit of maths also when you look at things like, for example, Newton's second law. So the acceleration that body experiences is equal to the force divided by its mass. Okay, so for example, if we've got, well, let's imagine, right, just at the very moment that person starts moving. Okay, so before there's any air resistance, their acceleration is the force of their weight divided by their mass. Okay, so the force of their weight, well, that's equal to mass times gravity. And if we divide by mass, that means acceleration is just 10. Okay, 10 meters per second squared. Don't know why I put a minus in there. 10 meters per second squared. Okay, that's the acceleration due to gravity. And we normally, when we do calculations, we ignore air resistance.